All right, hey, can we start?
And the way they'll move.
So today we're going to discuss unit circle, which some of you have said that you've heard some friends talking about or whatever else. I like to wait till we get through most of our content to discuss unit circle because I feel like it tends to make more sense then. So back when we talked about like angles of elevation and depression, this relates back to that. The unit circle can go either direction, but normally, and this throws people off, the positive direction of rotation is counterclockwise. Yeah, the positive direction of rotation is counterclockwise. So this direction right here on your paper, that's the positive direction, and Smarting will catch up eventually. That's actually the positive rotation. So that's why when we start this packet, you see that we always start from the x-axis that is positive and work going around left counterclockwise. Let me see if I can get.
Do you have any other good instructions?
Well, oh yeah, here. I don't know if you guys haven't figured this out yet. That pencil sharpener sucks, so I have to keep this one in my desk because I've had three of them walk away. So, what are some things you notice about this circle? How it's laid out on the coordinate grid? Just some observations.
It's a circle.
Yeah?
Oh, well, it's center at the origin.
Yeah, we've got its center at the origin. I still don't know where my smart ink is.
Red.
Maybe.
No, it's red. No, it's purple.
Come on, smart ink. I want you to open not as a web browser.
Hey, Mr. Hudson, could you go buy some pencil sharpeners?
What?
Mr. Hudson, have you seen
Yeah, I'll work on that.
Have you used Snoop?
I mean, just go ahead and like.
Yeah, I've seen it.
It's so bad. Do you see the intro?
Okay, it's
All right,
I will pay for it. If you
center at 0, 0. What else?
That's because they're.
Center at 0, 0. What else about the circle? Right here?
Diameter of 2.
Diameter of 2, radius of 1, which means that every time the circle intersects an axis, it is. There you go. It's at 1 or negative 1. So we could see that these points here and here, x is 1, y is 1, y is negative 1, x is negative 1. Anything else you see?
So you can basically use this for trig because
That's exactly what we do use it for.
because you can basically manipulate that line, the blue line,
The radius.
No, that's just a ray. Yeah.
Oh well, no, but you
sorry,
can
I
like
didn't see the end.
you can make that the hypotenuse of your said right.
Ah, so what Jacob's talking about is if I want to figure this out, I can drop a vertical here, I can run my horizontal here, and I can perform the trig functions that we know, sine, cosine, and tangent, to solve some of these things. Because if I know that this is 1, then my radius everywhere is 1, so this length right here has to be 1 no matter where it is on the circle. So now my hypotenuse is 1, and then I can figure out my leg lengths based off of that. The angle that we work with, we call theta. This is the Greek symbol theta. That's what we start to use for angle names. So angle theta is positive measured counterclockwise from the x-axis, counterclockwise to the terminal side. So where my angle ends is my terminal side. So that blue line that Jacob was referencing is the terminal side. Emily?
I kind of need a band over there.
I do not have any.
Staple your thumb.
You are. You stapled your thumb.
Yeah.
What are we doing?
Do you want to go to the actually go see if Gold Ring has bandage. I bet she does.
Gold Ring has like an unlimited supply.
I ran out. I don't. Kids must
My
like.
dad has some in his drawer.
Oh, do you want to
In
go
his
get?
drawer.
Do you want to go get her one?
Yeah.
What'd you think?
The princess, the really nice class.
Did you seriously
Sasha
say
knows the
you-
school
You can
inside
choose what
out.
princess
Is that how?
Have you been in the booth?
Yes.
you
She knows every
I'm betting
single
it's
crevice
Cinderella.
in the upper.
So the radian measure. What the heck is a radian? Anyone know how radians compare to degrees?
Oh, nope.
Or what are you gonna say about radian? Do you know?
It sounds like radius.
Okay, sounds like radius. There you go. Radian.
Okay, a radian. So a radian is the length of your radius, but anyway, so the radian is basically like, so if you have that circle and you take the radius and you try and fit that around your circle, then the amount of like degrees that takes up is a radian.
What?
I was about to say, can anyone communicate that in a different way?
In English.
Half of
It is the arc length of angle in the unit circle. It is the length of the arc created by that angle when we have the radius 1 in my unit circle. So you can use radians in other size circles, but that's why our unit circle uses a radius of 1, because it's a unit. 1 whatever, 1 centimeter, 1 inch, 1 mile, doesn't matter 1 of what, it just has to be 1. The radius has to be your base unit. So then your radian measure is the arc length. So if I come back up to my circle up here and I say I want to look at this being my terminal side, my radians would be from here to here. How much of the arc have we covered? Now with a circle that has a radius of 1, if I went all the way around the circle, what is the entire distance around the circle called? The circumference, right? Distance around circle. But Leon, you're right. What is the entire distance around the unit circle? 2 pi. So that's why here we see the reference angle is the measure of the angle from the terminal side of the x-axis. The reference angle is always less than or equal to 90. And this pi over 2, that pi over 2 is because 90 degrees. Say we're comparing from this side, 90 degrees. Well, if the whole circle is 2 pi, how much of the circle do I have right here? What fraction of the circle? A fourth, right? So we have a fourth of 2 pi, which equals pi over 2. So what we reference is that the entire distance around the circle is 2 pi, and we can figure out all the other radian measures based off that by how much of the circle have I covered. And we can set up, really how we got that 1/4 is 90 out of 360. And then we simplified. So the entire unit circle just uses the knowledge about circles that we already have. So, if we had the angle 210 degrees, and we wanted to figure out how many radians it was, like we just did with our 90 degrees, we just want to say, well, how much of the circle has been covered, or how much of that circumference? So we take the angle that we have, and we multiply it by this like conversion factor. Why do you think we're using pi over 180? Why are we using pi over 1? Think about, I just said conversion factor. Think about what other conversion factors we use. Love it to be somebody not Jacob or Leon. You guys are awesome. I got involved the rest of the class. What? So think of some, forget about the unit circle for a moment. What are other conversion factors we use? Say I want to convert inches to miles. We need a few conversion factors to do that. One of the first conversion factors you ever learn in elementary school. Seth? 12 inches is 1 foot. So if I was using that, I would end up having to put, like say I have 3 feet. Well, then that goes over 1. If I want to convert to inches, I'd have to put the feet on bottom, the inches on top. So I end up with 12 over 1. So why do I have pi over 180 here?
Okay, I'm gonna take a wild guess. You ready for this?
Sure.
So on the last one, you used like 1/4 times 2 pi, right?
Mm-hmm.
Is it gonna be like 1/4 times 360 pi?
Jacob.
Okay, so pi over 180 is basically a conversion factor. So you know that one pi radians equals 180 degrees.
These are equal. Your conversion factor, the 2 terms in your conversion factor have to be equal. So 180 degrees is half of the distance around the circle. Half of 2 pi is just pi. So the other way that we can actually do this, we don't have to use the method shown here. We don't necessarily have to use that conversion factor. If we didn't want to, where the heck did it go? We could set up 210 over 360 times 2 pi. Because I know the whole circle.
Could I please have John Debrea, Courtney Quickle, and Justin Villarreal to the office, please? Thank you.
I know that the whole circle is 2 pi. So if I say, here's my portion of the entire thing. But then, if I put this over 1, I know I multiply straight through the top and straight through the bottom. So I get 420 pi over 360. What can I do with stacked zeros?
Cancel them out.
Get rid of them. So 42 over 36 times pi. Or I can leave my pi on top if I want. 42 over 36, what's a common factor? 6. So 42 divided by 6? 7 over 6. That's how we can get the same exact thing. So whichever method you decide to use, I was taught, take your degree measure over 360 and then just multiply by 2 pi. So you know the whole circle is 2 pi. If you'd rather use the conversion factor of pi being equal to 180, you can. That is the exact same method. We're converting between degree measure and radian measure. The degree measure is how big your angle opens up. The radian measure is how much distance does that arc span. How much of the circumference. Right?
Well, what is 7/6 of pi?
That is how much of the circle has been covered. So we know since it's over pi,
So
it's more than halfway around the circle, because the whole circle is 2 pi. So 210 degrees, if I go back and I actually look at my unit circle, 210 degrees would be about like here, right? So to start here and go all the way around, but on the actual circumference, I'm saying how far is this? And that would be 7/6 pi. Because right here, if I was at 180 degrees, that is pi. So my 210 is at 7/6 pi. Yeah.
Just to clarify, you have 7/6 pi radians, right?
Yeah, radians. So we have to label radians. This becomes our label. So instead of degrees, it's radians. It's really kind of interchangeable as long as you know your conversion factor. So this is kind of one of those times where it's like, if it asks you how many radians, you can just give your answer as 7/6 pi because they know you're discussing in radians.
Oh, yeah.
It's like how many feet and you say 5. They don't assume you're saying miles. So same thing, converting backwards, but we flip our conversion factor upside down because what I want to get rid of now is the pi, and what I want to keep is the degree measure. So instead of using pi over 180, we use 180 over pi, and that can convert me from radians back to degrees. Any questions at this point?
Is the 180 in pi, is that always going to be the conversion?
I mean, there's other conversion. You could use 90 degrees and half pi, or 360 degrees and 2 pi. This is just the simplest because you only have 1 pi.
Okay.
Yeah, so that's the easiest conversion factor to use. Good question. Emily?
Yeah, so back on the last slide thing, it was all like 7/6 pi, right? But then, no, scroll down. Where did that
The ones that the one up on the TV? Yeah, you erased them.
Okay, but so then it was like pi over 3 for when you were like doing it backwards, right? Yeah, right there. No, down. No, the smart board.
Oh, this is a new problem. So it might help you if you draw a line. That's a different problem.
I know it's a different problem.
Okay.
That's not
So it starts in radians. Okay, so what's your question?
Rephrase my question.
That's what I'm trying. So now they've said if somebody tells you the radian measure
Yeah, I
of
get
this angle is pi over 3, how many degrees is it?
Yeah, but my question is, you converted the one up in the previous question to like 7/6 times pi, right?
Yeah.
But then that one's got it's in division.
So this could also be written 1/3 pi. Because remember, I can, if I'm multiplying by a value, it can go in my numerator or it can go out of my fraction. Does that help? Okay. So really what we start with here is 1/3 pi. So we know it's less than 180 degrees, because that would be pi. We know it's less than 90 degrees, because that would be half of pi. And we only have 1/3 of pi. So we take my 1/3 pi, we use my conversion factor, and we find out that is actually 60 degrees. Questions on that conversion? Any others? Okay, I think we're ready to practice a little bit. So we will find the angle given the terminal side's endpoint on the unit circle. So what we see now is the endpoint. We have my x coordinate and my y coordinate. Radius equals height equals so the height equals 1/2. So it's half up. So we have to figure out what is that angle. So this is done out for you, right? It's just a little spaced out. So we can use any of our trig functions, but what we know is the x value refers to how long this leg is. The y value tells me how tall this is. And if I'm looking, and I know my hypotenuse, of course, if I'm looking for theta, that angle in there, because we don't want to use this angle. We'll figure out that angle once we know the small angle here. But we want to use trig. So, of course, we want to make a right triangle. So we use that right triangle there. What trig function would be best? Well, I can use sine or cosine or tangent because I know all three of them. This whole thing has been trig. Like, what we're doing is just trig. So now we can apply our trig functions to make my life easier. Hold on. So, what we're really looking for is this unknown angle. I know the opposite side is 1/2. I know the adjacent side is negative radical 3/2. And I know that the hypotenuse is 1. So I could use sine, cosine, or tangent. Why do you think they chose sine? What is sine when you think about SOHCAHTOA? So sine of your theta, and I want you guys to write this out, sine of your theta, and if you want to, theta actually has like a squiggly middle, kind of looks like a Fabergé egg. Theta is just an angle. So you could say sine of angle x or sine of angle z. We just use it now to represent the angle we're working with. I know. So we could use either. We could use any of them. So we could use tangent. The reason we're using sine, it's going to involve a 1, which makes it easier. So I want you guys here on your paper to write sine of theta equals opposite, because SOHCAHTOA, over hypotenuse. I know that the opposite side that I have there, the height is 1/2, because that's the y value. And I know that the hypotenuse is a length of 1 because my radius has to be 1. Is anyone confused how I get 1/2 over 1? So then, to get theta by itself, what do we apply? Yeah, so trying to remember like cosecant and cotangent and all those, that's kind of difficult. I a lot of times refer back to inverse. So we use the inverse sign, right? So sine to the -1. So what they don't write out is that we really apply the inverse sign to both sides. So if I was going to write this out, I'd say I'm applying, so really this is sine to the -1 times sine of theta, so those will cancel out, equals the sine to the negative 1 times, well, 1/2 over 1 is just 1/2. So you could write 1/2 over 1, or you can just write just 1/2. That's how they jump from this step to that step. So right in between here is this. Okay.
How did they get 150 as their answer, assuming that theta is going to be
I'll show you in just a second. I'll show you. Any questions on why? I didn't erase it. Jeez, dude. Any questions why I did what I did? We're using inverse sine to cancel out the sine so I can isolate the theta. When you plug into your calculator inverse sine of 1/2, you get 30 as your answer, which tells me that this angle right there is 30. But I'm not actually looking for that angle. I only did that because it was easy to solve. What we're looking for is this angle. How will 30 and that angle relate to each other? Grant? They add up to 180 because they are a, what kind of pair? Supplementary pair. So since they're a supplementary pair, to figure out the green angle, we say, okay, what's 180 minus 30? That angle must be 150 degrees. That angle must be 150 degrees. We're in here till 53. Any questions on that process?
Wait, so then how do you go from the 1? Why'd you draw the arrow from the 1?
Because we're always, good question, we're always starting with this side, the positive x-axis. And this blue line, well, this blue line, my terminal side. So what we're trying to figure out is the amount, like the degrees from my beginning point, my positive x-axis, over to my terminal side. But I can't make a right triangle there. I could make a scalene triangle if I drew it kind of like this, but that's not what I want. Since I know this point, it was given to me, negative radical 3 over 2 and 1/2. Since I know that point, I set up a right triangle, use the trig to solve the interior angle, and then I just use the supplement rule.
But what is the interior angle?
This, theta, right here, this guy right here. That's why I was referencing opposite was 1/2, hypotenuse was 1. Okay.
So we always assume that the positive x-axis is going to be your starting point.
Yep, you
But
have to start at that positive x-axis.
will it tell you if it's anything else?
It can't be.
Oh.
For unit circle work, that's always your starting point. Yeah. Any other questions? That was a good one. The positive x-axis, that green line right there, that's always our starting point. Or starting line, starting side.
Just this one problem. Is this what we were doing earlier in the year with?
I mean, we were doing trig earlier in the year. Yeah, with sine, cosine, and tangent. So this is just relating those trig skills into the unit circle and finding unknown values. So, we want to use any process you want to convert these degrees into radians. We'll do a few together, and then we'll skip to the next section, and the next section we'll just do a couple of each of these sections together. So, any requests? 1 through 6.
We just do them all?
You can't do them all. We'll do one to start. So, one method that we can take is set your value over the total of your circle and then multiply by 2 pi. If I do that, I get 24 over 36, which is really 2/3 because I cancel my zeros. Stacked zeros I can cancel. And 24 over 36 really becomes
Wait, what did you just have after this one?
just times 2 pi, but I erased it so I can just move it over here. All we're trying to do is reduce down the fraction of how much of the circle have we covered. So we've covered 2/3 of the circle. My rotation, if I started here, I've gone all the way to 2/3 of the circle. I only have 1/3 left. From where I started, there's 1/3 left that I did not cover. So how many radians was that? I multiply by 2 pi, and I get 4/3 pi. Bless you. The other method we can apply, which we can use for 6, is the conversion factor that they gave me, or sorry, that we can use for 2 for angle 60, is just apply the conversion factor. What do you want to get rid of? A pi or a degrees? A degrees. So to get rid of that, if that's in the numerator, I have to put degrees in the denominator, and I put pi in the numerator. I'm going to have to slide my page over. So I use pi over 180, or we could just set this over 180 times pi, if that's easier for you. You can use pi over 180, or divide by 180, then multiply by pi. So 60 divided by 180 is 1/3, and we get 1/3 pi. Why what? Good? All right, let's do 330, and then we'll move on. Yeah, I mean, kind of. Like, we're going to keep working on this a little bit. I'd like you guys, by the end of class, I'll tell you exactly what you need to do. Because 330 is such a big angle, I'm just going to use the technique that we had used first, over 360, then times the 2 pi. That gives me 33 over 36, which I could reduce into 11 over 12 times 2 pi. Well, that gives me 22 over 12. Those share common factors of 2. 11 over 6, which is as reduced as I get. So we get 11/6 pi. We don't. We normally just leave it as an improper. So you can, but what we really work with is, because we know 2 pi is the full circle, we could say, well, this is only 1/6 away from the whole circle, so it's 1/6 pi negative or 11/6 pi positive, but that's easier than saying 1 and 5/6 pi. Like, that gets a little weird. So that's why we'll say 11/6 pi, because we know it's over a pi, it's over 180. It's past that. You can't, I mean, if you really like mixed numbers, you can write it as a mixed number. It's okay. Just my math training, we just always left it improper. So let's now do 7, 8, 9, converting the other direction from radians to degrees. So, gonna ask for some help here. What should I use to convert and get rid of my pi in 7? Who thinks they know? What should I use to convert? Cal?
180 degrees over pi.
180 over pi, because I want my pi on bottom, because that's what I want to get rid of. Anyone see what I can do right off the bat?
6 and 180.
Ooh, 6 and 180. I can cross reduce.
Can't you also cross reduce the pi?
Ooh, the pi's just cancel each other. So yes, kind of. It's cross reducing, yes, but I mean we don't really have to show it. It's just going to happen. So if I divide by 6, I get 30 and 1. The pi's cancel each other out. So 5 times 30, that should be 150 degrees. That's all you got to do.
That's much easier.
Wait. Why are we doing that?
Because even once I cross reduce, I still have 30 in the numerator here. So the pi's canceled, but the 5 is still there. Because when the pi's cancel, it becomes 1. So I work through the numerator, 5 times 30. I work through the denominator, I have 1 times 1. I get 150 over 1, which is just 150. That makes sense?
I don't think I was ever taught to divide fractions.
Really? Weird. Yeah, somebody failed you. Like, not they gave you an F, but they failed you.
I also was never taught division.
Neither was I.
You should write a letter of complaint.
I'm
Well, you
under
weren't
taught.
taught. You weren't taught
Mr.
what?
Hudson, long division.
Oh,
So I skipped 4th, 5th, and 6th grade math.
Okay? That a lot of times will lead to some holes in your learning.
Yeah. I didn't learn long
All right,
division.
8. Again, we're canceling the pi. I'm not even going to suggest you a different way to convert this. Easiest way always to go from radians to degrees is just 180 over pi. Can I cross reduce? The pi's for sure. Does 4 and 18 have a common factor? Or 4 and 180, sorry. So I can divide 180 by 4. So I can cancel out my pi's. They become 1s. My 4 becomes a 1. My 180 becomes 45. So now I have 5 times 45. I only have 1s on bottom. 225 degrees. And the last one here should be pretty straightforward. 2 pi.
Wait, so do you just multiply 45 by 5? Yeah.
2 pi. How many degrees? 360. The whole circle. And we could work through the work to show that math, but it just becomes 360.
I wish they gave us more of those questions. Can we just have a bunch of number 9?
Like, what is 1 pi? What is 2 pi? What would 3 pi be?
A circle.
One and a half.
Did that drop me? So now we have to envision the unit circle. And you have to realize that we have x and y giving the lengths of our legs. X gives you the length of your bottom leg. Y gives you the length of your vertical leg. And we know the hypotenuse is 1. So it might help, and this is why on the back of this, you have a blank unit circle that you can kind of reference to. If you want to try to think of where would radical 2 divided by 2 and then negative radical 2 divided by 2. Well, okay, so I know I'm a positive x value, but a negative y value. Positive x value, negative y value. What quadrant am I in?
4.
The 4th quadrant, right? Because if you remember, your quadrants are numbered 1, 2, 3, 4, again, counterclockwise in motion. So if I have a positive x and then a negative y, think about this as this leg's length is radical 2 over 2. Remember unit circle?
What?
Remember unit circle? How fun that was?
Oh yeah. Last.
Then my other leg is also radical 2 over 2. Even though it's negative, a length can't be negative. This is where people make mistakes. A length cannot be negative. So if I use this, I make it positive in my trig function. Did you have a question?
Wait, but what if it like
I do have some.
A length cannot be negative. Is that what you're trying to argue?
Yeah, if you're like measuring the length of your arm and instead of your arm being there, it like there's a hole in your chest where your arm would have.
So if you were able to measure something, you'd get a positive value. Jacob.
So, to solve this, you don't have to go through all the sign stuff.
Okay, how so?
Because we know it's a 45, 45, 90 triangle.
Okay, so because I see that my legs are the same length, I know that this angle that it makes, this theta, must be 45 degrees, but that's not your answer.
Yeah, you have to add that to
Wait, why does it have to be
270.
Sorry. Would you ask, Greg?
Why does it have to be 45?
When I see a right triangle with two legs that are the same length, and my third leg is obviously the hypotenuse, it's got a length of 1, but because both my legs are radical 2 over 2, I know it's isosceles, so it has to be a 45, 45, 90. Any right triangle with two matching legs has to be a 45, 45, 90. Is that clicking now or no? Greg?
Oh, yeah.
We could do the trig. If that doesn't like come to your,
I see it
you can
now.
do the trig. So because of that, I see that theta is 45, right? So theta is 45 degrees. But what I actually am trying to solve here is this angle. So to figure that out, what math do you do?
3 times 90.
Not 3 times 90.
3 times 90 plus 45.
Or just do 360 minus 45. We've gone the entire circle except for the last 45 degrees, and that gives me 300, should be 315 degrees.
That makes sense.
Why do I see people choosing to not write things down? Like, do you think this is magically going to be easy when you go home?
Is there homework?
Yeah, this packet. If you noticed on the TV when you came in, it said unit circle packet.
But I wasn't here on the
Let's do another one here. Yeah. So 17 is the same thing, but it's in a different location. So 17, what I would do if I was you off to the side, it's negative x, negative y. So I would draw that you're going here, there, and you're looking at,
Yeah, so it's just 180 plus 45.
yeah, it'll be 180 plus the 45. So 17's easy. You're just going to have 180 plus the 45, which will give you 225. Because we see it's another isosceles triangle. The legs are the same length. So since I know the legs are the same length, these two angles have to be 45 degrees. Since I know this has to be 180, I just add 45 to it. Let's do 15 because it's a little bit more of a difficult one. So 15, with all of these guys, it will help you immensely if you at least draw your little crosshairs and determine where is it. Where'd my x go? Where'd my y go? And try to label some things. My x is positive, so I come a positive 1/2. My y is negative. It goes a negative radical 3 over 2. But because length has to be positive, when I do the trig, I'm going to look at it as a positive. So if I'm looking for theta, put my 1/2 up here. So we're looking for theta there. We're going to need to use some trig. Which is easier to work with? The opposite side to my theta or the adjacent side to my theta? Why is adjacent easier to work with? Yeah, half is way easier than radical 3 over 2. So if I want to use adjacent and hypotenuse, what trig function? Toa. Cosine. So cosine of theta will be the adjacent 1/2 over 1. Again, we then have to apply my inverse cosine. Inverse cosine of 1/2, and you got your answer.
Wait, that was like the first one.
What is the inverse cosine of 1/2? Jacob, you got it? You compute it?
Oh, that's 30, but.
This is 30?
But you can also see that it's a 30, 60, 90 triangle by looking at the ratios.
Well, okay, yeah. I mean, if you want to analyze it. I'm trying to make sure that we support understanding how to do the trig. But again, that's not your answer because that's theta.
That's not cool.
I called it.
Theta's 30. So then my angle's actually 360 degrees minus 30.
330.
So that's a 330 degree angle.
That was nice.
You chewed me out, fam.
Don't trust theta. You probably always have work to do beyond theta. That's why you draw the crosshairs. Try, hey, math 2. Try to get through 18 done. Try to get through 18. You should have most of it done already. Try to get through 18 in the packet done.